See that.
But this is going to be like a review of everything we've done
Yeah, it should.
today, right?
Yeah, it's
So it should be pretty easy despite being 30 questions.
so I asked our teacher if I really had to have 4 hours to take this test. So I've got 5 kids, I have to schedule my time, and we only have between Monday and Wednesday.
Yeah.
He said most people take between 1 and 1.5 hours, but if we like to take our time, make sure you've got the 4. I'm like, okay, that's good to know.
My computer charge just dropped from 2.5 hours to 45 minutes.
Nice.
Awesome.
I feel like that's how it always is. I always bring my cord. I can't trust my computer at all.
Yeah, I usually do, but today I forgot it. I don't know why. For the first time. Do you have your HP charger here? Might need it. Except yours might be bigger than mine. All right, we'll just. I might just drop out.
If you open the quiz right now, you have to open an SS file, and that's going to take a little bit. So if you want to try to start opening that already.
Yeah, well.
I thought that everything that are review questions, I thought that's what the quiz was going to be. That was my understanding. Is that what your understanding was?
I don't think so. I think that's just review for the quiz.
I thought that
Like
was review
similar
for the
questions.
test. I thought that's what it said.
Well, review for the quiz is review for the test, and that like homework was review for the quiz and the test.
Okay, I thought I read that.
I don't think it's the same questions though.
I thought it was. I thought it said it was. Let me go see where I got that idea. I got it from somewhere.
Yeah, it says inside the quiz you should take it once before you meet with a group, and then a second time with your group. But that's weird because it didn't. Because nothing said before that we needed to do that.
See, it says in individual preparation, the same problems found in this review are on the group preparation quiz. I don't know if it's same numbers. Maybe he means same type.
Oh yeah, the first one is which of the following variables are categorical, and it has the exact same.
See, okay, so that shouldn't
questions.
take too long then, as long as we understand stuff. Okay,
Yeah.
SPSS open.
So I guess we'll see if our teacher says anything about taking these quizzes before we meet with the group, because, like I said, I didn't see anything like that from before. I'm not sure where Deanna and Julian are, but I figure if we get started on the quiz now, we can just catch them up to speed pretty easy.
We should start
Yeah,
for the sake of me not losing connection.
Yeah, and I have class,
Do you have
if I mean anything to you too.
There was one thing that I read through, and I did not recall it from before, and it was in the review from the chapters, and it was also on here. Which one was it? It was the standard, okay, number 23. What is the mean and standard deviation of the standard normal distribution? That's the special case one, where the mean is 0 and the standard deviation is 1. Correct?
I'd have to what number?
23.
That's not the same for our quiz.
Yeah, what is the probability that randomly selected students will score below 600 on the GMAT? Yeah, it's different.
Well,
when we get to that,
doesn't apply to the 23 stands alone. It's a standalone question.
I know, but it's not number 23 on the quiz, is what I'm saying.
Oh, okay.
But when we get to that, if we do find that question though, we can definitely talk about it.
What was the question though?
What is the mean and standard deviation of the standard normal distribution? In our notes from the chapters, and I don't recall that from the chapter, said that the standard normal distribution is a special case scenario in which the mean is 0 and the standard deviation is 1, which makes sense if you think about it, because normally it's not going to be that. But I wondered if you had come up with the same thing. So that's all.
Weird.
Anyway.
All right, are we gonna start? Are we gonna
Yeah,
wait?
let's just start, and then we'll catch them up when they get here. Because I have
Okay.
class in an hour, so. Which of the following is our card categorical?
Is it just the two that aren't number of animals in the local zoo?
I thought it was that one because categorical, doesn't that mean it's just there's a fixed number that you can choose, where if you randomly choose, then it's not fixed?
Wouldn't that be quantitative? Or am I backwards?
Yeah, I don't know. Maybe I'm backwards.
No, I think it's categorical because like number of animals in a local zoo is a quantity of animals versus the age in years of randomly selected vehicles. That's a category, you know.
Well, but the
You're not counting
age
20
number.
cars. Number, but you're not counting the amount of cars in the parking lot. You're counting.
No, you're counting the age in years, and that's going to be different per vehicle, right?
Yeah, so it's a category. So you're going to say blank cars were 1994, blank cars were 1995, instead of we had 16 cars.
Let me open up my, I still haven't opened my quiz. Okay, hang on.
I know it was like 4 weeks ago that we did this kind of stuff.
I thought that was, which ones are categorical? I think it's just the
It would,
toothpaste.
if that was the case, it'd just be the last one, because if we were going to randomly select a brand of toothpaste at a convenience store, there'd be a set number of those there at the location, whereas if we randomly selected vehicle,
Except
I don't
it
know.
wants the years of the randomly selected vehicle, so that is numerical.
Well, it's just saying it's just saying if you chose one vehicle in a parking lot, how many years old is it? If you just chose one brand in a convenience store, how many items of that brand are there? And then if you go to a zoo, what exact number of animals are in the zoo?
So we're all agreeing on toothpaste.
Yep.
Right? It's just the question of the parking lot. I say we just choose whatever you think is right, move on. Because I remember that being kind of like a confusing point for me, like the very first lesson.
Yeah.
Yeah, what?
I remember that too. I remember confusing.
Yeah, it was confusing. I remember thinking like, oh, it has numbers involved.
The cereal on the shelf or something. I think that's the only question I missed.
And I remember it being like, well, I remember thinking that like it involves numbers, so it's quantitative, but something that's like an age is like a characteristic of the car. It's not like blank cars. Like you're choosing one car and that happens to have a year attached to it. It's like a telephone number.
Are we just saying toothpaste then? Or toothpaste and zoo?
I'm pretty confident about the. Yeah, we can just come back to it too.
Let's come back to that.
And you get a second retry, so it's either one or the other.
That's true. That's true. Good point. I will start that. Go back. Okay.
All right, 3.
100.
The following statements is true. Well, they're all statistics, aren't they?
Well, no, the parameter is the definition of the group population. And the other one is,
so that'd be the parameter.
112 is a parameter.
The estimate of the parameter obtained from a sample.
Ooh.
So 100 is the parameter because it's the population mean.
And then 112 is the statistic, right? Aren't both of those true?
Sounds good.
Okay, 4.
I would think a stratified sample.
Stratified. Is it not cluster?
They're asking what kind we should collect.
Mhm.
So it doesn't
So we
tell us
want-
what they did, but if you get some out of each of the different neighborhoods, because that would be, you wouldn't want a cluster because then that's just using one of the neighborhoods, right?
Okay.
Well, clusters where you take a group and then you do a simple random sample of the cluster. But we want to ask every.
But we don't want that one, right?
So we want
I would think
stratified.
if you want, yeah, if you want a good representation, you'd want a sample from each of those neighborhoods.
Mhm. Yeah.
You agree? Okay.
I agree. So is 5 looking more like a cluster?
Yeah, that one looks like a cluster to me.
So clusters where you take a group and then you do all of them.
Right.
Oh,
It's using all of the 4th grade students. So you take all the 4th grade students in the district, and that's a cluster.
okay. Yeah, like I haven't even thought about this in like a month.
I know it. Okay, school fundraiser.
Okay, so when it's do a cluster, like I said on the problem before, I'm pretty sure a cluster is where you take the group and then you do a simple random sample of each of the groups. So I think 4 should be cluster and 5 should be stratified.
Cluster is defined as all items in one or more randomly selected clusters or blocks.
Yeah, so when you take a cluster though,
Number 4, you want to go back to 4?
when you take a cluster, you take a group from an area, like so a neighborhood, and then you do a simple random sample of that cluster.
But that would only be
No,
from
no.
one of the neighborhoods.
The cluster
no.
sample is using all of the ones from that block. I have the definitions right in front of me.
Okay.
I already did my study notes for my test, so they're right here because I can't remember without that. The stratified divides the data into similar groups, and then they take the simple random sample from each group. So that's
Okay.
the stratified one that we want for the
So I just had them
right?
backwards. So,
Yeah.
Okay.
And the grouped one.
So 4 is stratified.
So we had them right then.
4
So
is stratified,
6.
yeah, and it's
5 is cluster.
5, yeah. And then at the
And
school
then-
fundraiser, that would be an SRS, correct?
SRS, yeah.
Is there?
Well, it's kind of a every person attended, yeah, so SRS.
I'm sorry, say that again.
Nothing, I was just agreeing with you out loud.
Okay. So are we good with that one, Ron? Are you going to move on?
Yeah.
Okay,
Yeah.
7.
So would that be systematic random sample?
That'd be stratified again because they took 2 groups and then did a simple random sample of them.
Yeah, I agree.
Stratified?
Yeah.
Stratified random?
Uh-huh. Now we need the crossroads stuff. Let's see if my SPSS is open.
My SPSS still isn't open, guys. My computer does not love it.
It was the crossroad purchases? Okay, here we go. I assume these are the same questions, but I will open it up and do it again. Here we go. Make this small. Oh, why is it doing Excel? I didn't ask for Excel. Go back up. Wrong one. Online. Biostatistics. There we go. Try that again. Crossroads. I explained why it opens so quickly. Excel doesn't take nearly as long to open. Okay, let me see what the questions are. They might be the same ones that I answered before.
Did it want us to do the frequency of the amount spent?
Calculate the mean of the amount spent.
From my previous data, I had it as 4.7711, but I need to go and make sure that's still the case after it opens again. Do you have yours open, Ron? Or did you do this one?
Yeah, I'm just trying to get it to go.
SPSS? Does that affect your computer speed?
Come on, SPSS. So your
I got
SPSS works, Tim, in other circumstances?
I got 4.77.
Yeah, 4.77. How many decimals do they want us to round to?
3.
So 771.
Yeah.
My SPSS usually on the school computer, and then when I do these group quizzes, I have to use my camera
Okay.
and my this, so I don't have it on my computer.
Standard deviation I had as 1.912. Counted to the third decimal. Is that what you have, Ron?
Yep, 1.912.
Okay. You got that, Tim?
Mm-hmm. So these are the same questions as our homework.
Yeah, so far. Mostly, yeah, I think so. Okay, so let's see. Next page. 2.7, 3725, 3898, 3816. So I have the mean is 38.075 for those 4 seals. Representative temperature. So go to the chart below that. Seems like forever that we did this too.
So wait, so you create the histogram, and then did you already move past that one, or are we on 10?
Yeah, I'm just starting to look at 10.
Oh, sorry.
I said, yeah, that I created a histogram. That was just a true false thing.
So that doesn't have anything to do with the ones after that, though.
That's an accomplishment one.
It's just as long as you know how to make a histogram.
Yeah,
Oh,
yeah, I
okay.
think that's really, yeah,
That's
that's
where I
all
was
it's saying.
confused. I'm like, why am I making
I
this?
created a histogram. True, yes or no?
Congratulations, me.
Yes, pretty much. One of those achievement-based questions.
So we're just using
Participated in my group, guys. Okay,
the 4 seals this time.
Got 4 seals here. I have the mean as 38.075 between the 4 of them. So let me double check my numbers.
38.075.
38.075.
Deviation from the mean. 37. So A is going to be a negative.
Negative 0.165 for A.
Yeah, 0.165. What is the value that goes in B?
Oops. 165.
Did you get 0.680?
0.681 I got when rounding.
For A, did you get a negative number?
For
Yeah,
A,
A's negative.
0.165.
Or so negative 0.156. Is that what you got?
We got one. We both got 165.
What did I do wrong?
What mean are you using? Maybe my mean's wrong.
No, I got we got the same mean, 38.075. So 37.91 minus 38.075 is 65 negative. It smells like Christmas trees in here.
We're getting ready.
It smells like Christmas trees.
It's not a bad thing.
Okay, I got the right answer this time.
Cool. What quantity is equal to the sum of the numbers in the squared? That's standard deviation, right?
No, that's the variance. If you want this,
Variance?
Yeah, isn't that the variance? Pretty sure that the sum of S squared column is the variance, and then you have to take it to get to this, to the standard deviation. You
use the variance to find the standard deviation.
Of the, yeah,
okay, for 12, you guys got 0.6 8-1.
Yes.
Okay.
And so that
The variance.
the deviation squared.
Oh, no. Yeah, 13's none of these are correct.
I thought that was the
What's
variance
the
sample.
what's the variance then?
The variance is you add them all together, then you have to do something else.
No, that
Remember?
ends up being, yeah, you add it all up and then that's the variance and then you take the square root and divide it by the number of
Of the
data
sample
points
size.
minus 1 to get the standard deviation.
Okay, I just remember my wife yelling at me really bad about something about adding them all together, and it wasn't an actual answer. You had to do something, but before it came an answer.
Right. Yeah,
Well,
but that was when we were computing the standard deviation by hand. I went through all of the book again and everything. I'm certain it's the variance.
let's go with variance, and if it's wrong, then we have
we'll
numero
know.
dos, and it's a simple fix.
It's true.
Sorry.
So
the standard deviation would be what? The variance over the square root of the sample size?
I'm sorry,
No,
say that again.
I was speaking falsities.
Sorry, I'm still looking through my notes. I'm trying to figure out what order these are in. Okay. Yeah, the variance is s squared in my notes.
The variance is s squared. Does that mean you have to square them after you add them together?
Well, the s squared is that third column. S is
Oh,
the
okay.
deviation from the mean from in our little chart table thing there. And then the s squared is the variance. And then to get to this deviation, you have to take the sample's standard deviation, you have to take the square root of that. But first, actually, you have to take the sum, the number minus 1, divided by that, and then take the, so that's how you get to the standard deviation. Sorry, what number are we on here? 13, 14. You take that sum, which I have, it's 2.24975. Divide it by, we've got 4 numbers, so divide it by 3, and then take the square root. And I believe that's the standard deviation, which is the same thing I did here. So I'm guessing that I had that right, which is 0.866 if you round. What do you think, Tim? What do you think, Ron? Yeah, where are Julian and? I don't know where they are. You guys there?
Yeah, So I'm going back and looking at the homework where we did the thing, because for when you add the column, you get a number and then you divide that by n minus 1,
Right,
and
which would be
that
3.
gives you the variance, and then you take the square root of the variance and that gives you the
That's
standard deviation.
deviation.
So the number, when you add them all together, doesn't mean anything.
I have it listed somewhere in the text as the sample variance is s squared. I have it listed in 2 places.
Okay, I'm just saying when we did that homework, the number it told us didn't mean anything. So
Well,
that
I got
means
it from somewhere. I didn't make it up.
means that this variance.
So S would be the sample standard deviation is what I have written down, and that the S squared is the sample variance. And then if you want the sample standard deviation from that population or from that sample group, that you, yes, divide the sum of those S squared by n minus 1 and then take the square root for this standard deviation. I wrote it in a lot of places, so I'm pretty sure I didn't make it up. And I went through the text yesterday, all of the notes, to try and make sure that I remembered it. But we can, if we get that wrong, then go back and fix that. Have a second try.
So you took that, you added them, and then you divided that by n-1, so by 3, and then you took the square root of that. Okay, what'd you get for that?
0.866 if you round to the.
Okay.
Did you get that?
I don't have any paper, so it's kind of hard to try to put it all in my calculator.
Okay.
So, but I believe you. I understand where that came from.
The sum, yeah. Okay, so I'm going to circle 13, and we need to go back and look at this one too. Just to make sure.
Okay, so 15. Can the standard deviation be negative?
No.
No, because since you square it, or take this, yeah, since you square it, it can't ever be negative because, yeah. I can't get out what I'm trying to say.
It's also a distance from the mean. It's always a distance from the mean, and that
can't have a negative. Yeah, that's true.
Can't have a negative distance. So are we happy with false on that one?
Yeah, definitely.
Okay, 16. Let's see if these numbers are the same. 6, 3, 4. Yes, 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 yes. All right. Oops. Which location resulted in the most consistent measurement? That'd be the extradural, since it's the smallest standard deviation, right?
Yeah, 3 or well. Yeah. It doesn't matter what the sample size is, does it?
I don't think so. You're looking at the smallest.
Yeah, standard deviation. Right? Yeah. Extradural.
Yeah, extradural.
Okay. What is the third quartile?
What did you say?
Oh, I was talking to myself reading the next question. Okay. Sorry.
All right. The third quartile, 8.
8, yeah, that's what I was saying.
Okay. 4 and 8 hours. What percentage of data lives between 4 and 8? That would be 50%.
Yeah, but don't put it as a decimal. It says. Okay. So 50%.
Good noticing. It's just 50. Just the number 50.
Mm-hmm.
Okay. I'm glad he gives us little guides like that. That is so helpful.
Yeah.
All right, let's see. All right. Yeah, these questions are not exactly all the same, but they're okay. Move all my notes over here. Okay. Unusual. This is the same one, I think. The city or expert. So that's 2 standard deviations, and those are the points at which those are. So estimate the mean. Wouldn't we just take the difference and divide it by 4? And then either add that to the, or divide it by 2, I guess, if we're moving from the 2, and then add that quantity to the 1.59 or subtract it from the 2.52. Is my brain going the right direction with that?
Yeah, so did you get 2.055?
2.055,
Because the mean should be directly between them.
Right.
Yeah, okay.
Yay.
So okay. Now once it's estimate the standard deviation, so we know what 2 standard deviations does. So it's the same thing, just divide your answer by 4, I think.
Yeah, so 0.233.
That's not what I got, so I didn't do it right, I guess. I didn't do something right.
Okay, so the difference between the 2.52 and the 1.59 is, divide it by 4. I'm getting 0.2325.
Oh, I know what I did. So you needed to take the 2.52 and add the mean, and then divide that by 2. And so then you get, oh, never mind. I'm wrong again.
Okay.
Subtract them. 2.52
Let me start from scratch too. 2.52 minus the 1.59.
Did you get 2.3?
3. And we got 4 deviations there. So we need to divide it by 4. 0.233, yeah.
Yeah, okay. I don't know if we got to the number the same way, but we all got it right. Okay.
As long as we've got the, that's part of what, this is definitely was one where I was like, pretty sure we haven't done this, but okay, let me put my data together and my understanding and try to apply it. Okay, so 68 of the data lies within 1 standard deviation. So that would be, what would the mean again? 2.055 plus the 0.233. So I have
288 on the upper end.
2.288 and then 1.823.
Yep, that's the only one that can be right. Mm-hmm.
Okay. Standard deviation 120.4, 5, what's the probability that a randomly selected student will score above 542.3? So you want the z-score. That would be 0. I wonder if you can't actually score like a partial point or something. I don't know. I wonder if that's what they're trying to tell us, is that nobody could score that exact number, but it's the mean.
No, I mean, the answer has to be 50% because the probability that a student will be above that, if the mean is that number, then half of them have to be above and half of them have to be below.
Right, but the z-score is 0, right? That's what my brain is not.
Yeah, technically
which would equate, yes, which would equate with the probability being 50%.
Yeah.
Okay.
So 0.50 on these?
Yeah, I think on that one.
As long, I don't want to, I want to know if he wants like 50% again or if he wants the decimals. Seems.
Well, it's the probabilities. He wants the decimals.
Decimal, yeah.
I think so.
Below 600.
So the below 600 z-score. Let me open it up. Below 600. Oops. Come on. Be 0.477.
And it wants below 600.
We'll score below. So the bottom 2 ones shaded.
So 684.
684 is what I got.
Is Tim still there? We lose him? I haven't heard him in a while.
I don't know. Let me go back to the Hangout and see if he's there. It has his picture. I mean, his thing.
Oh, I can see him moving. I just can't hear him.
Okay, maybe he muted.
So hopefully he agrees with us.
684. Hopefully he'll chime in if he doesn't agree with it.
We'll score 600 or above on the GMAT, so that's just going to be
the opposite.
316.
Yeah, 316. You got me all doubting on that variance thing.
Find the GMAT score that corresponds to the 10th percentile. So 1. Oh gosh.
The lesser part, and the 10th percentile G-score is. Oh, we got the G-score, right? Oh, the G-score.
We need to highlight.
Put it in there.
Yeah, so it's a negative z-score, right?
-0.1282.
Mm-hmm.
And then you got to plug it into the z-score formula.
Times 120.
And add 542.3.
Plus.
Round to the nearest whole number.
388.
I got 388. Is that what you got?
Yeah, I think Tim just.
You just leave. I just got a text. Can you not hear me?
I can't hear him.
I can't hear you either. Can you hear us?
guess we'll wait for his text. See if you can hear it. Are your headphones not plugged in all the way? Poor Tim. 90th percentile. It'd be the same thing, right? Just positive.
Acidic. Or what you still want the, yeah, it's the positive Z-score, and then you want everything below it. So I got
He can hear us. We just can't hear him.
697.
Oh, sucks. I'm plugging it in real quick. Sorry.
No problem. No problem.
So 160 or 697. Is that what you got?
Yes, 697. Okay.
Whole numbers. Okay, the first quartile of the distribution of the GMAT scores. So 25
percentile here. 0.25.
And
you score negative 0.674.
674. I hate having to scroll up to go look at those numbers again.
Oh, I just wrote it on my paper. You don't have any paper though.
Yeah,
that makes it harder.
Since I don't have like a desk to sit on. I'm like sitting on a bench, and so it's like impossible to eat.
Yeah, that makes it a little harder.
461, is that what you got?
Yeah, I have 461.
Okay. Third quartile, and it's gonna be the same thing, just in the opposite direction with the positive Z-score, right?
Yep.
Wait. Yeah.
Yes. My son is watching Winnie the Pooh. Halloween. 624 is what I got.
Yep.
Okay, that's good. I'm glad Tim is following along. I'm glad.
624.
Yeah, I got 624.
For a random sample of n equals 15 students. It's the mean of the distribution sample.
Okay, so this one we have to calculate. Okay, the mean is still the same. Deviation there is going to be.
So the mean's still going to be the same.
What is that symbol? The standard deviation, is that sigma?
Yeah.
O with the tail or whatever it's called.
Maybe. I'm not sure. I don't know all.
My son told me yesterday. He's like in calculus BC. He's like, yeah, that's a sigma, Mom. And I'm like, oh, I thought it was.
So it's 542. Oh, 42.3. It says round to the nearest tenth, so 1 decimal place.
What's the mean? Oh, I thought it was asking us. Yeah, the mean is 542.3.
And then the next one is the standard deviation of the distribution of sample mean. So this one's the one we're going to have to take the old standard deviation.
Yeah, the sigma thing divided by the square root of n, which would be 15, they said? I forgot how many samples they said. Okay.
So 31 point,
15.
I don't know how far out we want to go.
1, 2, 3.
Yep, 1, 2, 3, 31.123. What is the probability that the sample mean GMAT score for an eyes greater than 6?
We went 3 decimal places. 31.123. Okay, with the 15 students, that will be greater than 600. Let me go to the output. Greater than 600. That Z-score.
So we got to find the Z-score first. So 600 minus the 542.3
divided by the 31.123. I got 1.854 for the Z-score.
Yep, same here.
And then we've got probability of 0.0319.
Yep.
How many decimal places? So 0.032.
Mom.
Yes.
What do you need, honey? Is your show over? Do you need me to get you a different show? Yep, do you want to go do it by yourself? Yep, you got the remote. Do you want to go do it by yourself, honey? Dude, that's all of them. Okay, do you want to go back to that first question?
Yeah.
Okay. Or the second question? Okay, what I'm thinking is I want to look at my
so
sample categorical. So I have categorical variables as labels data without any workable numbers. I guess I'm not sure with that age and years of randomly selected vehicle, if that's, I'm not sure if they're using that age and years as a data point between different vehicles, or if because it's just inferring that it's one randomly selected vehicle, that would be categorical.
Sorry, what was
that's what I'm confused about. That was number 2. The definition is labels, for categorical labels, data without any workable numbers.
So it can't have any numbers that like.
Well, it can have numbers, but it has to be numbers that aren't going to make a difference in the data set. So I guess it depends on how they're using that, is what I would argue.
I know
if they're using that and selecting one vehicle, because it says vehicle,
Mommy, stop talking.
then it could be categorical. And if it was more than one, then it could be, okay, we have 5 random vehicles and the difference in the age of the vehicle is a data point. And that's my fine line that I'm not sure which way to go. Does that make sense?
Yeah, but I
don't know.
I don't know. I just don't. It seems so confusing to me. Maybe if I go back and look at the homework, because the homework made us do a bunch of them. You know.
It did, and that's the only one that I think I got wrong on that. And I just didn't buy it, and I don't know. Christopher, can you go watch your show, or do you need me to help you? Do you need me to help you with it?
Mommy?
Yes, sweetheart. Let's rewind it for you, okay? Does that work or not? Okay, there you go. Go try that. Let's see if that works for you. So we can go back and look at it. What do you want to?
I'm just looking for a second, see if I can get any
I went back to the text, and I went to, and I didn't ask the teacher to. I probably should have. I should have said, please give me a very easy understanding of this, because
what lesson was
I can
that?
see either side. That was lesson 2, I believe.
That was not better.
That was not better, my guy. I'm sorry.
Isn't that?
I'm sorry, honey. There's one other one that I wanted to look at again too.
What did I want to know again?
Variance one, remember?
Yeah, 13.
The 13 one.
Categorical.
The way that I break it apart in my brain is, are we going to use those numbers in our data? Or is it just saying, I have a 1967 Chevy, and that's its definition, then it's a label. And if they're saying, okay, we have all these cars that are sitting in the parking lot, we want to know what the mean and standard deviation is of the age of the cars. Then,
so in the zoo, you would use the number, definitely. You definitely.
Yes,
so that's a no. We're not using that one.
Right.
In the toothpaste,
it's a brand.
It's a brand, so there's no number, and then age and years.
See, that's where I'm having.
Yeah, so confusing.
I know. That's why. And I can see them arguing either side of that.
Because you could be like, how many? I mean, you could be like, I'm just looking at a 1970s car, or
right.
Then the 1970 doesn't matter. Whereas I'm looking at cars that are 20 years old, then even then it doesn't matter. It's just.
But it could, if they're saying the age and years, if they pick a parking lot.
Yeah, they're looking.
And they get the years of all of those vehicles, and that's their data, then it would be quantitative.
I think it's just the toothpaste then, because I think age and years, like specific amount of years, they're probably going to use that data. So let's just stick with toothpaste.
Okay, if it's wrong, then we'll go back and we'll have to maybe get teacher to clarify that.
Okay, 13.
Is that 13?
No one's here.
There's nobody here. I'm talking to somebody on the computer, though.
What is it?
My 3-year-old said, nobody's here. Who are you talking to?
No one's here.
Where his
Do you
computer
want me
must
to
have
talk
died.
about standard deviations, guy?
No, I need to do. There's
Okay,
no
so
that
one.
just
Oh,
day.
okay, sweetheart.
There's no the rest of the fenders. Day.
See, I had, when we were doing
This-
that calculation of the standard deviation by hand, I needed labels in my brain to keep things straight. And so I went and looked stuff up, and so I could have labels for
Mommy.
things. And I don't think that it was as clear in
Okay.
the text.
Mommy.
So if you go to the text in lesson 3
Mommy.
Uh-huh.
and then go down to step, it has like 5 steps. I don't know what they're for, but step 5 says divide the sum of the squared deviations by n-1.
Uh-huh.
Right, this is the bottom of column. The number you computed is called the sample variance. So it's the addition of all the squared deviations being divided by n-1.
Okay.
So that's where I was thinking that it's not going to be adding them all together isn't giving us anything.
Okay, sweetheart, just a second.
Fingers.
Is equal to the sum of the numbers. So, okay, so I see where you are. Let me, I'm writing that on my paper. So I have.
So as soon as you divide them, it's the sample variance, but right before that,
Okay.
it's
so let me
just
find-
a nonsensical number that doesn't mean
Where did I write
anything.
that? Where did I write that? It's just a means to an end.
Mommy.
I know I wrote that down.
Mommy. Mommy.
Christopher, just 1 second,
There's no
honey.
the rest of the fenders. Day.
I'm
No
not sure I
rest
put this in here in the
of
right
the
place, so I'm gonna.
fenders. Day.
Christopher, if you want the Avengers game, we gotta go put it in. So you're gonna have to wait.
No, we don't have to wait.
You do have to.
No, you
I don't have to wait.
don't.
It's so funny.
Don't have to wait.
Okay, so let me
You
write.
don't have
That's just
to
a sum. And then
wait.
divided by, okay. I know I wrote that somewhere. I wrote it next to that.
Well, I get what you're
Divided
saying
by
though, because in the
n-1.
beginning of the sentence it says that once you compute it's the sample variance, but at the end it says we denote the sample variance by the symbol S2.
S squared.
Yeah, S squared.
See, maybe that's C. So this is another, what do you really mean? Because you're saying two different things.
Yeah.
I'm gonna,
What's S though? What's
S?
S?
S is
On its
the
standalone.
sample variance. It's the deviation from the mean. It's
S
from
on
the
its
sample.
own,
S on its own.
like without this.
Yeah.
It's
It's
Yeah, I
considered
don't know.
several
I
different
guess-
things. It's X minus the, yeah, it's the data minus the mean, and it's considered a sample variance and a deviation from the mean. That's what I don't like. I'm like, can you just be consistent and call things what they are and stop changing what you call them? Drives me crazy. It's like my psychology class. Hey, here. You go watch a show.
Okay, we'll just have to submit it because I've got to run to another class.
Okay.
Why do I don't
But
play it and it is?
So which do you think it is, Ron?
Why do you leave
Do you
that
think
this
it's the none?
morning?
I'm gonna
Why
put a
do
big
you put
question
out
mark here.
the star?
I got a
Why do you
93.
leave this out on morning? Why do you
Who
leave
did?
it out?
Tim?
Morning?
I did. I just submitted it. The one I got wrong was 14. The standard deviation of the temperatures. I think that's, also
Christopher, I need my calculator, honey.
No, that's
I got 6 wrong. 6 was wrong.
6.
6, that's the one about a school fundraiser. The name of every person who attended was entered into a drawing. And then we said stratified random sample. And it must have been voluntary response.
Yeah, voluntary
Maybe.
response. I guess makes
Because
sense.
that's,
Because it was
yeah.
just those that attended, right? So it was a. like a
because
convenient
not
sample.
everybody.
I'll go through these.
Does it show every question on that? Oh, interesting. Well, I'm gonna end the broadcast so I can post it real quick before I run off.
Okay.
All right, I'll see you later.
Okay. Bye.